students. On this clip, we're going to be going over the definition of dependent and independent events, and then we're going to look at some examples. So, write down the definition first. Let's start. So, write down the title first. Independent, and dependent events. All right. So dependent events, dependent events are actions that affect the same bucket, same, the same set or bucket. I can put the word bucket. Okay, they're connected somehow. Whereas independent events do not change or alter the set or bucket. Okay. All right, so what are some examples of dependent events? Let's say people on Mars and aliens on Mars and people on Earth. That's an example. So let's write down an example. Example of independent are people on Mars, and people on Earth. All right, the people here and the people here. All right, the people on Mars, of course, they're aliens, right? So if you're selecting aliens on Mars, it doesn't affect the number of people on the Earth because they're independent. They're from separate sets. And then selecting people on Earth is not going to affect the aliens on Mars. Another example, let's just take a look at dependent events, for example. What if we want to look at dependent events? Dependent events, or how about the male and the females on Earth? Okay. So we have let's say this were Earth, and we had the humans. Humans can be broken into male and female. All right. So the male and the female on Earth are dependent because they both affect the humans on Earth. All right. Male and females. All right. So when you take one male from the Earth, the number of humans goes down. When you take one female from the Earth, the number of humans goes down. So selecting males and females from the Earth actually affects the number of humans on the Earth. So that's dependent. Okay? Alright, now let's take a look at some examples that on the worksheet that you have. So we have 4 examples to look at. Example 1, it says state whether the events are dependent or independent. Number 1, finishing first, second, or third place in a 10-person race. So it's 10 people. So the first is coming from the same bucket, the second is coming from the same bucket, the third is coming from the same bucket, right? So since they're all in the same bucket or set, it is dependent because one person can be everything, right? So this is dependent. Choosing pizza size and the topping of pizza. The size and the topping are 2 separate things. All right, the size does not affect the topping does not affect the size. So in this case, since they are 2 separate buckets, this one is going to be independent. All right, number 3 says 75 raffle tickets are placed in the jar. 3 tickets are then selected one after the other without replacing the ticket after it is chosen. So we're selecting from the same bucket and we're not replacing. Since we're not replacing, then it automatically makes it dependent because we're changing the set. Every time we pull out something from the jar, without replacing, we're actually changing it, so it makes it dependent because it alters the set. Number 4, 232 members of the freshman class all vote by secret ballot for the class representative to the student senate. Um, so, so for this one, each person is voting, right? One person's vote does not affect the other person's vote. So in this case, they're all separate. Since they're all separate, this one is independent. All right. If you vote for Obama, for example, it doesn't affect the vote for somebody else. So everything is kind of separate. All right. So when everybody's casting their own vote, one person's vote does not affect another person's vote. My vote does not affect your vote. Okay. Everything is separate. So that's why this is independent. All right. Let's go ahead and try some more examples on 5 to 11 on the worksheet. All right. So on number 5, take a look at number 5. It says the surveying firm plans to buy a color printer for printing its maps. It has narrowed its choice to one of 3 models. Each of the models is available either in 32 megabyte, 64 megs, or 128 megs. How many combination of RAM does the firm have to choose? So, all right, so this is going to be an independent situation. This is independent. It's independent because each bucket is separate. You have the 64 bucket, we have the 32 bucket, and the 128 bucket. So they're all separate, so it's independent. So we have 3 of them. We have the 32, 64, and the 128. All right. So how many of each do we have? We have 3 of this. You could choose from this. It could be. All right. So for the first choice, out of the 3, he could select. For the first choice, it could be 3. Out of the first 3, you have 3 choices for 32. After 1 is selected, he has now 2 more choices to make for the next set, and then 1 choice for the last one. And then when you multiply everything, 3 times 2 times 1, we're going to have 6. All right, let's take a look at number 6. How many different arrangements of the 3 letters can be formed using the words math if any letter will not be used more than once? So we have 4 spots. 1, 2, 3, 4. We want to create a 3-letter word. Okay. How many letters does the word math have? Math has four letters. Okay. So for the first spot, we have 4 choices. For the second spot, 1 is taken down. We have 3, and then for the next spot, we have 2. All right. So we'll multiply everything together. 4 times 3 is 12 times 2, 24. Okay. All right, let's take a look at number 7. Number 7, it says Alan is playing the role of Oliver in his school's production of Oliver Twist. The wardrobe crew has presented Alan with 5 pairs of pants and 4 shirts that he can wear. How many possible costumes consisting of a pair of pants and a shirt does Alan have to choose from? So we have 2 spots here. We have the pants spot and the shirt spot. How many pants can he choose from? 5. How many shirts can he choose from? 4. 5 times 4, 20. Okay? All right, let's look at number 8. It says a 10-member steering committee that is preparing a study of the public transportation needs of its town will select a chairperson, vice chairperson, and secretary for the committee. No one person can serve in more than one position. In how many ways can the 3 positions be filled? So this is going to be a dependent situation. We have 3 spots that we want to fill. We want to fill the chairperson spot, the vice chair, VC, and then the secretary. How many choices for the chairperson? There are 10 people, right? So we have 10 choices, 10 people that can fill this position. After one person has been taken, we have 9 people that can fill this position. After one person has been taken, we have 8 people that can fill this position because no person can serve in more than one position. So you can have one person be all three, okay? It has to be one person per position. So 10 times 9 times 8 is 720. All right, let's take a look at number 9. It says Janine has decided to buy a pickup truck. Her choices include either a V6 engine or a V8 engine, a standard cab or an extended cab, a two-wheel drive, or four-wheel drive. How many possible models does she have to choose from? So we're going to look at the engine. We're going to look at the cab. First slot is engine. Next one is cab. And then the next one is the drive. How many kinds of engines are there? Two kinds of engines. How many cabs are there? Two kinds of cabs. How many kinds of drives do we have? Two kinds of drives. So 2 times 2 times 2 is 8. Your answer is 8. Alright, let's take a look at number 10. It says a mail order company that sells gardening tools offers rakes in 2 different lengths. Customers can choose either a wooden, plastic, or fiberglass handle for the rake. How many different kinds of rake can a customer buy? Okay, so we're gonna classify. We have 2 spots, right? We have the lengths, probably short and a long, and handle. Okay, how many kind of lengths are there? There are 2 lengths. How many handles are there? There's wooden, plastic, or fiberglass. 3. So how many possible different kinds of rakes can be created? 2 times 3, which is 6. Okay. Number 11. Mexican restaurants offer chicken, beef, or vegetarian fajitas wrapped with either corn or 4 tortillas and topped with either mild, medium, or hot salsa. How many choices of fajitas does a customer have? So I'm gonna say choice of either this is either chicken, beef, or veggie for the protein part, and then for the carbohydrate or the carbs, we have either corn. I'm gonna call this. Let's just call this carb. Okay, call this carb. This is the carbohydrate part, and then this one is the toppings. Okay. So for the veggie part, or I mean the protein part, we have 3 choices, right? 3 choices for either beef, chicken, or vegetarian. And then for the wrapping of the carbohydrate part, we have 2 choices, and then for the topping, we have 3 choices. And then we'll multiply everything together. We get 9 times 2, which is 18. 18 different kinds of fajitas can be constructed using these options that are provided for us. Okay? So these notes are available on YouTube. You can view it later on, okay?